Hi there, I'm Hao, and this is just another video of me solving random code problem. So let's begin. So we need to solve like Sudoku solver here, right? So the rule of Sudoku is that each column will have a number from 1 to 9, right? Exactly one. So you cannot like have duplicates, right? The same rules go for the row, right? Each square contains of a number from 1 to 9, and it has to be unique across the row. So it would be exactly number one, number two, so on and so forth, right? And the third rule is that it has to be exactly we have to have like exactly 1 to 9 in each subsquare, right? So 1 to 9, right? Appear exactly one time, just like the row and the column, but for the subsquare. Okay, so how are we gonna do this? So each square, right, can have we can try like we can have like 9 possibilities, right? So let's look at the time for so if we have an empty row, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So if we have number 9 here, right, which means the only numbers that we have left is 8, 6, 7, 6, 5, 4, 3, 2, and 1, right? If we place 5 here, which means the remaining uh, square, we're gonna have only 7 numbers left. So on and so forth, right? And so therefore it is a factorial, right, of 9, right? So a factorial is like a permutation. So how many ways can you arrange a set number? So in this case, 9 number from 1 to 9, right? How many ways can you arrange 9 numbers in a row, right? You can. So for example, right, let's start simple. We only have 3 square, like 1, 2, and 3, right? So how many ways you can arrange number 1, 2, and 3? So we can have like 1, 2, 3, right? And then 1, 3, 2, right? 2, 1, 3, 2, 3, 1, right? And then 3, 1, 2, and then 3, 2, 1, right? Which is set combination, right? Which is the factorial of the max, right? Which is 3. Sorry, of the total number of the factorial is the total number of di digits, right? So this is only 3 digits, right? So 3 factorial equals to 3 multiplied by 2 multiplied by 1 equals to 6, right? So we have 6 combination here, right? So similarly, how many ways can we arrange 3 numbers? We have 6 ways of arranging 3 numbers, right? In a unique way. So similarly, how many ways can we arrange 9 numbers, right? Which is the 9 factorial. Okay, so that is for one row. And then we have how many rows do we have? We have 9 rows, right? So that is to the 9. Right. So because we have this is for one row and we have 9 columns, right? So it is nested, right? So it is to the 9th, right? So if we have like a 2 for loop, it'll be n square, right? So yeah, this is for one row, this is for the column. But it is a backtracking approach, right? So if we use a brute force approach, right, which we have 1, 2, 3, 4, 5, 6, 7, 8, 9 path for each square, right? And we have 81 square, right? It would be 9 paths, so 9. The length is the depth is going to be 81 square, right? So 9 to the 81. Right? So this solution, the backtracking is much more efficient than the brute force approach, right? And I want to make it clear that even though this is factorial and stuff, but the actual runtime payload will be over 1, right? Because the number of square, number of row and column, right, for the board for the Sudoku board gonna be 9, right? 9 by 9. It's never gonna be changed, so we don't have any N and M, right? The input gonna be like the same. So it is a constant type. Okay. So we can iterate over each row, so each row, each column, right? Or sorry, each square. And if the square is not occupied, right? We're gonna try it with like a number, right? From one to 9, right? So we're gonna have like 3 for loop here, right? 1 to 9, yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, yeah. 1 to 9, right? If 1 doesn't work out, and we go back and we change it back to 2, right? So on and so forth. Okay. So how do we know that the board is solved? The board is solved when the whole board is filled, right? There's no more dots, right? Because we only run the backtracking when there's a dot, like an available space to run. But if it is no more dot, we finish the whole loop, right? Then we're gonna return true. So we don't have to return anything here. When we I think we can just modify the word directly, right? So every time we place a number here, right? Let's say we place 6 here, like let's say we place 2 here, right? How do we know it is valid? So we can check the row and the column, right? And uh the square that the number is belong to, right? Right. And if we look at like any square, so for example, right, if number 2 here, the position is gonna be 1, 8, right? Right. If we take 3, we multiply by the matter floor of I, which is the row here divided by 3, right? So I is 1, or 1 divided by 3 is 0, right? Oh no, not really. The row is, wait, the row is, yeah, 1 divided by 3 is 0. Yeah, correct. And 3 multiplied by 0 is 0, right? So we know that the star of our square, right? Star x, right? The star of our square, position x, right? Going to be 0, right? We can do the same for uh the column, right? So the column gonna be 8, right? So 8 divided by 3 is 2, right? Because we before that multiplied by 3 is 6, right? So our star, the square of the y position gonna be 6, right? So 0, 6. So we can see that 0, 6. So 2 is here, right? 0, 6. So 0, 1, 2, 3, 4, 5, 6, right? Right here will be the star of the square, the star of the square that the input number is belongs to, right? Yes, and actually let's build out the is valid Apple function. So con is valid, right? Equal we take check in the row, the column, right? And the input, right? Input number, the num. So we're gonna index equal to 0, because so now we need to check for the row, the column, and the square, right? Index less than let's create a variable for max equal to 9, right? And the min equal to 1. So our number go from 1 to 9, right? Index plus plus. Okay. So if something, we're gonna return false, right? If nothing is violated, we're gonna return true again, right? So we can do the board, right? Index and then row equal to the number, or the board at index at the column, right? In the index, is equal to the norm, right? Or something else. We don't know yet. Okay, let me clear some space here. Okay, so for this part, right? So let's say we are checking for the number 2 here. So our row will be 1, right? This is our row, and the column will be 8, right? So first column, so we're going to do index, right, is 0, 1, 2, 3, 4, 5, 6, 7, 8, right? And the row gonna be 1. And actually, the row should go first, right? Yeah, the row should go first. The row should go first, and then the column should go second. Right, my bad there. The next, okay. So the row should go first, right? The row. Let me change color here. Let's make it more obvious. So we have a row, right? Column. It is 1, 8. So the row over here, 1, 1, 1, 1, 1, 1, 1, 1, right? So 1, 0. Yeah, 1, 0, 1, 2, 1, 1, 1, 2, 1, 3, 1, 4, right? So this is checking this row right here to see if we have number 2 yet, right? If we already have number 2, which means it is invalid, right? Because we need to have exactly 1 initial, exactly 1 number from 1 to 9 initial. If the input is 2, right, then there cannot be any odd number 2 is in the row, right? So similarly for the column, we have 8, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, this there will be our column. Right, so index and then the column. Index is the 0 to 8 here. Right, so 0, 8, which is right here, right? 0. So we would be checking this column right here, right? Right, 0, 8, 1, 8, 2, 8, 3, 8, and so forth. So and then so on and so forth. So yes, so if 2 is the input, then we cannot have the second number 2, right, in the column. And if it is, we're gonna return false, right? Okay, so that's just it for the row and the column, right? How do we check for um the square? So we need to know the star of the square, right? So we can do star of the square x, right? And then or we can do square row, square x, and then square y equal to let's make it 2 line or equal to multiply by the matter floor of I of the row, right, divided by 3. Same here, but for the y, and now it is the column divided by 3, right? So as I explained earlier, right, if the position is 1 and 8, right, 1 divided by 3 is 0. We floor that, right, and we multiply by 3 is to 0. So 0 will be the square x, right? And column is 8 divided by 3 is 2, multiplied by 3 is 6, right? So 6 would be our square y. So 0, 6 right here would be the start of our square, right? That the input belongs to. Okay. And we want to check, right? The square. So you want 0, 0, 0, 1, 0, 2, and then 1, 0, 1, 1, 1, 2, and then 2, 1, 2, 0, 2, 1, and 2, 2. Okay. Right. So we know the star of our square, right? So we know the start of our square is 0, right? So we want the x to stay in the first row, right? For 3 times. So we can do the square x here, square x, right? Plus the math of floor of the index, right? Divided by 3, right? So remember the square x here gonna be 0, right? 0 plus something, right? And from the index, right, go from 0 to 9, right? 0 to 8, sorry. So when it is 0 to 2, right, divided by 3, gonna be give us 0, right? And on the second row, when when the index is 3 to 5, right, it will give us 1. And when we are 6 to 8, right, give us 2. Right? 6 divided by 3 is 2. Right? So in that way, we can stay in the first row for three times, right? 2 digits, 3 times, right? So this is our intended x, right? So that is what our square x should be, right? We want to stay in the first row for 3 times, right? For the columns, we're gonna have the square y, right? Plus the mat dot floor of index mod 3, okay? Why we are modding by 3? Because if you look at the column, right, it is changing every time from 0 to 2, right? Repeatedly 0, 1, 2, 0, 1, 2, right? So if we mod by 3, so um when the index is 0 to 2, right? We're gonna have exactly 0, 1, and 2, right? When the index is 3 to 5, right? We're gonna have 3 mod 3 is 0, right? 3 mod 4 is 1, and 3 mod 5 is 2, right? Which is exactly what we want here, right? Same for this case, right? 6, so I wrote opposite here, so 4 mod 3, and then 5 mod 3, or 6 mod 3 is 0, 7 mod 3 is 1, and 8 mod 3 is 2, right? So by using the mod here, we can get the column to be repeating from 0 to 2 over and over again, right? So 0, 1, 2, 0, 1, 2, 0, 1, 2, right? And for the row, we're going to stay here 3 times, 3 times, and 3 times, right? So that's why we use the divide. Okay, so we can do the form of the square of x, right? Plus the multiplier of the row divided by 3, right? And the column would be square y plus the multiplier of the column, right? Hello? Okay, yeah. So the column would be square of y, right? Plus the multiplier of column mod 3. Wait, for the column mod 3, we don't need the floor, right? This is going to be that, yes. Okay, and then we look at the value, right? In the box, in the square, and we need to compare it into the input, right? The num, right? So if the input is 2, which means they can only 1, number 2 in the box, right? After we iterating to the box, right? If we found any number that is equal to 2, then we're gonna return false, right? And we don't have a semicolon here. We put it in the if statement, right? Makes sense, right? So yes, so basically we're gonna have the row gonna be so the start of this way gonna be 0, right? So 0 plus 1 is 2 is 0, 0, right? So 0, 0, 0 here, right? And then 0 plus 1 is 1, 0 plus 2 is 2, right? And for the column, right? The start of the column is 6, remember? So 6 plus 0 is 6, right? Plus 1 is 7, plus 2 is 8, right? So this index would be exactly the index of this square. Okay. So yeah, that's it for the valid. Right. So we can create a few variable here. Let's say the rows equal to border length and the columns equal to the border zero dot length. Also the same thing. So we have to iterate over the row and the column, right? And same thing for the column. Okay. And then if we only want to try a number, right, from 1 to 9, if the current cell is empty, right? So if the board at row and column is equal to the dot, right, is empty, then we want to do something, right? So at this cell, at this single cell, we want to try 9 number, right? All possible combination to find number. So let num equal to min, right? Num is less than or equal to max, and then num plus plus. And we want to try at row column is equal to the number, right? Let me back to string because this is a string, right? You see the input here is a string, so we need to turn it into a string, and we're gonna unselect it at the end if that doesn't work out, right? Set it back to a dot, and we can call the recursion function to backtrack, which is the solve Sudoku here, right? Sudoku solve uh, Sudoku, right? Passing in the word, and if this return true, right, we want to return the board, return true or return false, right? Or return true, yeah. Or we just want to, return because it's not asking us to return anything, okay? But we if that didn't work out, right? Which means we want to return false, right? We want to return false so that it will reset the board. So we can unselect the cell, right? Back to the dot. Anyway, so we can return false here. Right. So after we try we try all combination for number, right? If that doesn't work out, then we want to return false, right? Because the cell that we are trying, right, the empty cell that we are trying, uh, doesn't work for all numbers from 1 to 9, right? But if it works, we want to return 3. Right? Okay. Here, which means the Sudoku is solved. Right? If it is returning true here, right? If we iterate over the whole board, right, the whole row, any row and row columns, right, and we couldn't find any empty slot, which means the board has been solved, so we return true here. Right? And if we return true here, we're just gonna return here. Right? We don't have to return true here. We just return here and set the board back to but if it is false, right? If it is not solved, and we want to unselect the cell and try the next number. And if we try all numbers and this still doesn't work, we return false, right? And yes, before we even want to try the number, right, we need to check if the cell is valid or not. Right? So if we have to put our helper function here is valid, right? So if it's valid, we pass in the row, the column, what else? Row, column, and then the input number, right? So num, string, okay. It is a helper function, so I should have an underscore, right? So we only want to select the cell if it is valid, okay? So let's recap. So we iterate over each row and column, right? And we only process the cell that is empty, which is dot here, right? And for each cell, we want to try all combination of the number, right, from 1 to 9. So that is this for loop, right? And we only want to put the input number, right, onto the board if and only if it is valid, right? And what does valid mean? Valid mean is the whole row that we put the index, right? We put the number doesn't contain that number, right? It is unique across the column, across the row, and across the square that it belongs to, right? So if it is valid, then we put it on the board. And we call the Sudoku function again, passing in the partially solved board, right? And it just keep going until the board is filled, right? If the board is filled, we're not gonna find any more empty slot. Then we're gonna return true here, right? And if it is returning true, we're gonna exit and just return, right? Because the board is already solved, in place, right? But if it is false, then we can set the board at that cell, right, back to a dot and try the next number, right? Try number 2, number 3, number 4, and so on. And if we already try all possible number for that single cell, and that still doesn't work out, which means we need to return false, right? I think I should also return true here to be consistent. Okay, so that's pretty much it. Let's try this. Okay, so what am I missing here? Let's see. So I return or I pass in the board here. Makes sense, right? Uh, we check the is valid function, check the rise in the row, column, and a number. Okay, and we set the board to this number, and then we return true if it is solved, right? And then if not, we set back to a dot. We return false if nothing is working out. Okay, this look correct to me. Hmm. Let's double check the is valid function. So we have the index going from 0 to 8, right? Max 9. And the square is going to be square x and square y, right? Row divided by 3 and whole divided by 3. The board of row index equal to num, index column equal to num. or the square x plus index divided by 3. Oh, right. Uh, it should be index, right? Not row, because we are trying to use the index here, not the row. Because if we use the row, we only have the same answer, right? We are trying to use the index here, right? So if the index is like 0, 1, 2, right? The row gonna be 0. But if the index is from 3 to 5, you're gonna on the next row is 6 to 8, we on the last row, right? So on and so forth. Okay, now it works. Yeah, let's submit. And thank you for watching.